and things like App Engine, Cloud Functions, and Cloud Run, which we're going to talk about today. Machine learning, and those are all Google Cloud services that are serverless in a way, right? And then a few years back, we started looking into this new thing called containers. Containers have been introduced have been democratized by Docker. So they became easy because of Docker, but containers existed way before Docker. We used to do containers a very long time ago. And we started doing containers because, they have a lot of good properties. They allow you to write code in any programming language, any binary, any library. They allow you to do granular version control. There is already an ecosystem of base images you can start with. You don't have to build images yourself from scratch. It's really nice tool. But what containers certainly allow you to do is enable this thing we call portability. Portability is essentially the promise that you are able to write code once and run it everywhere. So you only write the code once, and then you can take that code and deploy it to any application, to any platform that runs containers. That's essentially, or at least in a way, that's like a utopian version of what reality is about today. It's not really today possible to just run containers everywhere because containers are not supported on all the platforms. And that's why 5 years ago, Google introduced this concept called Kubernetes, right? Kubernetes is a container orchestration system. It's a layer that allows you to take a bunch of containers and run them on a bunch of distributed virtual machines. So really to enable this portability. Then a few years after Kubernetes was released, the community got together and they wanted to simplify Kubernetes even further because Kubernetes is quite complex. And then they introduced a new tool called Knative, which is what Cloud Run is based on. And this is what we're going to talk about today. So Knative is an open source layer on top of Kubernetes that allows you to run containers in an even easier way. Initially, Knative was built to do three things. One of them is actually being able to be a CI/CD platform, so a build platform. But later, that build function have been disconnected and put into its own projects called Tecton. So what is Knative? Knative is open source in building blocks for serverless on Kubernetes. It's a bunch of pieces of code that has a unified API that allow you to run applications, serverless applications on top of Kubernetes, essentially. It looks like this. It's a layer, as expressed. So you have to have a Kubernetes layer under the hood. Then you have the Knative layer in the middle, which has build, serving, and events. Those, we call them the primitives. The build is what today is known as Tecton. And then on top of that, you have some sort of developer product that you use to build and run your applications. At Google, we took Knative and we run it on top of our platform, and we call that Cloud Run. It's a way to run stateless containers on Google fully managed compute platform. It's quite new, and I'm gonna try to explain it further today. So Cloud Run comes in two flavors. There is a fully managed version, and there is a Cloud Run for Anthos version. Today, I'm gonna focus on the fully managed one, which is the one that we have on GCP. And that's essentially a truly fully serverless platform, right? But regardless of which flavor you use, the whole point of Cloud Run is that you, as a user, you will interact with it using the same tools. So you will have either a user interface, a command line, or a YAML, and you will use these three things to basically run and deploy applications on top of Cloud Run, which runs on top of Knative, as I explained, which on one side, on the right side here, it's the fully managed version. On the left side, it's the Anthos version. This slide has like a little comparison between the two flavors, if you want. I'm just gonna put it here and share the slide later. You can read it as you see fit. But basically, essentially what Cloud Run allow you to do is run a single command line here, gcloud run deploy. If you have used Google Cloud before, gcloud is our command. And basically you just do a run deploy, give your service, tell it which image to run, and it will run the container for you. And we will scale up and down those containers based on demand, essentially, automatically. What you can do as a user is you can set some amount of memory and CPU, some amount of concurrency and stuff like that. I'm going to talk about these details later. Once you deploy your application, we will generate an HTTPS link. So we protect the application directly behind TLS certificates. the link is automatically generated. So there is a part of the link which is not predictable. You cannot know it upfront. So in order to make it easier for your user, you can add what we call custom domain, where you can map the link of the service to a domain that your users will use to access the application. In this case, mycustomdomain.com, for example. You have some built-in metrics and logs. So whatever your application is writing to the logs will be automatically collected for you and available in the interface. And we also have some metrics for you to check, because of course there is a layer of load balancer in front of your application, so we can collect metrics at the load balancer layer. Autoscaling in Cloud Run is defined by two things: the maximum number of containers and the concurrency. I'm going to talk about this in details, but basically we autoscale each service independently from the others based on the incoming requests. And then when you are deploying a service, we actually deploy multiple revisions. So you can roll back to a previous revision if you want, in case you introduced a mistake or you introduced a bug, or you just made a mistake in your code. So on the left side is an explanation of what we call concurrency. Concurrency is essentially how many requests each container can handle or will handle. So for a concurrency of 1, each time there is a new request coming in, we will just spin up a new container. For a concurrency of 3, we will have each container handle 3 requests. A higher number of concurrent requests per container means that you have fewer what we call cold starts. A cold start in a serverless environment is essentially the time it takes between a request coming in and the container starting. So we call that a cold start. So the more concurrency you have, the less cold starts you're going to have, essentially. And yeah, let's do a quick demo. I'm just going to look at the time. Yeah, we're good on time. So if you have used Google Cloud Platform before, you can go to this interface. So this is the Google Cloud Platform interface. This is the Cloud Run menu. And we're just going to create a service using the GUI. So I'm just going to go ahead and click on Create Service. Then I can choose, do I want to use the fully managed version or the Cloud Run for Anthos? I'm going to do the fully managed version. And I'm going to choose Europe North 1. Then I'm going to give my service a name. I'm going to call it Nginx because I want it to be called Nginx. Then here I have to provide an image. So I have already an image that I have here, an Nginx image. So I'm just going to pass that as an image to the service. And then if I click on advanced settings, I have a bunch of stuff I can play with. I know, for example, that an Nginx server listens on port 80. So I'm going to put port 80. Then I will have to memory allocated. Yeah, I can play with memory and CPU. So I can go from 128 megabytes of memory to 4 gigabytes. And then from 1, 2, or 4 CPUs I can choose. So that's how much resources are going to be allocated to every single container. I can choose the maximum number of requests per container. We talked about this. This is the concurrency. And then I can choose, do I want to have 0 as my minimum instances, which means when my application is not receiving calls anymore, it will scale all the way down to 0. And then what's the maximum amount of instances we're going to run? And we're going to auto scale in this boundary between 0 to 1,000 in this case. If I want to keep at least one container up and running all the time, so the first user to hit my application will not have a cold start and will not have like a spinning disk and have to wait, I can set that to be 1. And then I can set the maximum number of containers to something like 10 or 20 or whatever. Next, and here is the last setting, which is basically I would allow unauthenticated invocations, which means I don't request my users to be authenticated to get to my application. And with that, I'm just gonna hit create. So you can see here, it's going to start up deploying my application. It created a revision for me in here. And I have already an URL. If I click on this URL, I just have Nginx. So pretty straightforward. Now I can create new revisions. I can do a lot of things, but I'm not going to do that. I'm going to now show you a little bit more advanced features. So I'm going to show an app. You can see here that I have an app written in Go. Let's go ahead and look at it. It's basically a main app that has that. When it starts, it tries to look for an environment variable called port, all capital. This is the environment variable that gets passed by this value here. Sorry about that, revisions. Yeah, this port value here, right? That whatever you put here when you're deploying the application is passed to the application as an environment variable called port. So here I try to fetch it. If I don't, I set the variable port to 8080, and then I start an HTTP server that listens on that port. So it's either 8080 or whatever I pass through the environment variable. And then I have a HTTP handler, which essentially also tries to look for a target environment variable. If it doesn't find it, it sets this variable to world, and then prints hello, and then whatever the variable target has as a value. So it would either be world or whatever I pass through an environment variable. And I'm going to use this to demonstrate how we can use environment variables later. So I'm going to go ahead and deploy this. But before I can deploy it, I have to build the image. There is an alpha function right now where you can actually write one command. I think we can try to do it. And I haven't actually used it, so I don't know how it works. Yeah, no, sorry, I cannot use it. I know why, because my container has to be, my code has to be in a GitHub repo, and this code is not in a GitHub repo. So I'm just going to go ahead and build my container. I could either use Docker to build it. I am going to use Google Cloud Build, which is another kind of build platform. So I'm not going to build the container locally. I'm going to build it remotely. So gcloud builds submit, and then I have to give a tag to the image. So it's because it's a container registry, it will be gcr.io/the project ID/hello world. So this is going to take the code from my folder. It will look for a Docker file, which I have here, and it will build using this Docker file, essentially. Pretty straightforward. Since this is a build, the remote build, I have a link that I can actually copy and go and open in the console to see what's the build status, if there is any error codes and stuff like that. Sorry, yeah, so this is just an output of a Docker build, essentially. Like if you have used Docker build before, you would know what is this. So I'm just gonna wait for my build to finish. It will take a few seconds. My Docker file pretty much is straightforward. I am using what we call a Docker multi-stage build. So I have a builder that I use to do a Go build. And then I have an Alpine tree, so that's a slim image that I use to run the binary, essentially. So now I have my container here. It's built. This is the URL. Now, in order to deploy this application, I just have to do a gcloud run deploy, give it a name, and then give it an image. And that will tell me, do I want to call and do I want to allow unauthenticated invocations? I would say yes. And this will deploy my application for me. So if I go back to the Google Cloud Run interface, I should see that a new application is here and it's already deployed. There is an URL and it says hello world, as I demonstrated earlier. Now let's actually see how we can use environment variables. Remember that I have this target environment variable here that I can pass. I'm just gonna redeploy the app, and then I will do a set environment vars targets. I believe this is correct. I hope so. So I'm just gonna redeploy the application, but I will pass a target environment variable to Algiers, which will basically be printed after hello. So in theory, if I did everything correct, if I go back to this URL and just refresh it, I should have the environment variable. Now let's look at this. So we talked about the logs. I can see here that I have the logs each time I'm trying to connect to the application. It knows that I'm trying to connect from Chrome, so it tells me that. And if I look at the revisions, I should have deployed 2 revisions now. Yeah, so there is a new revision. So each time you are updating the code of the application and pushing it or updating some parameters, there is a new revision that will be created, and 100% of all the traffic coming from this main URL will be forwarded to that revision. And this is done to allow me to do rollbacks easily. So imagine, for example, this new revision I pushed has a bug or an error. What I can do is I can go here, manage traffic, and then have 100% of the traffic go to the previous revision, which is XAM, yes. So I click save, and this is going to do a rollback. And I hopefully, if I go to my application URL and refresh, I am back to the hello world. And yeah, that's it. I didn't want to go too complicated. There's 20 minutes in. I'm going to leave you with a few more links if you want to read more about it. The first link is the documentation. The second link is some free code labs that you can actually follow to build on Google Cloud Run and learn how to use it. The third is like an hour-and-a-half YouTube video where I demonstrated some more advanced features that you can just watch whenever you have time. And with that, thank you very much. And I think we can take questions, if there are any questions, of course.
I guess until now we didn't have any question. I will see with the team.
Right.
Do we have questions? I guess there is no question.
All right. Thank you very much for having me.
No. Thank you so much, Mr. Abdellfetah. It was an honor to have you here among us, and I wish we are gonna meet you in more occasions and more events with more topics, beneficial topics. Thank you so much.
Thank you very much. Have a good one. Bye.
Thank you. So for who is watching now, we are going to pursue the journey with Devfest 2020 with the next talk soon. So stay tuned.